Adding and subtracting rational expressions. There's a huge difference between adding and subtracting and multiplying and dividing. So before we get started, let's go ahead and write out the steps we're going to use. Alright, so the steps we're going to take are: step 1, finding a common denominator. Step 2, combining like terms. And step 3, simplify. You have to be very careful because there's a tendency to work backwards by canceling out values that you just used from your common denominator. So be very careful about that. You'll notice that's why the second step here is combine like terms rather than cancel. We're going to combine like terms before we simplify. Please keep that in mind. It's a very important step, and it's easy to get caught in a backwards motion by canceling what you just used from your common denominator. Alright, so common denominators in rationals are when the quantities on the bottom of the fractions are equivalent. Since they are, we'll move to step 2, which is combining like terms. 2x minus 5 over x plus 4. Look for a way to simplify your quantities. Since there's no GCF and no identical quantities, we are simplified, we are done. Common denominators in rationals are when the quantities at the bottom are identical, and since they are, we'll move on to step number 2, which is going to be combining like terms. The important thing here is that we're now subtracting, so you're not adding 3 and 6 together, you're adding 3 and negative 6 together, which makes negative 3. X and negative 4 minus 1, which is negative 5, divided by the common denominator of x squared plus 1. Again, there's nothing to simplify, so we are done. Question number 3. You'll notice here that we have 3 different parts in our denominator. We have a 3, an x, and a 7. It's important to note that the common denominator here is not x squared because I have an x in both of my numbers already. However, if you do choose to use x squared, it's no big deal. It'll just factor out at the end and cancel. So whether you see it or not, you want to use one of each of the terms that are on the bottom. The 3 numbers that are on the bottom of question number 3 are 3, 7, and x. So the common denominator is going to be 21 times x. What's missing from this one to make 21 is the 7. So I'm going to multiply this side by 7 over 7. What's missing from this fraction to create 21 is 3. So this side I will multiply 3 over 3. So now that's going to be 14 plus 15 divided by the common denominator of 21x. Simplify if possible, but that does not simplify, so we are finished. Alright, now here's where it gets a little bit tricky to see, but if you remember that x squared is x times x, there's already an x here. So in fact, the only thing I need to add over here is another x. When we look at these, as if you do too much, it's not a big deal. It's just that you have to do an extra step later. So notice that the common denominator is going to be 4 and x squared. That answer is 4x squared. One of everything that's on the bottom. What is missing from this denominator to create 4x squared is another x. What is missing from this denominator to make 4x squared is a 4. So that's going to be 3x minus 8 divided by the common denominator of 4x squared. There's no GCF here, and there's no way to simplify out these quantities, so we'll be finished. Alright, question number 5, and the rest of the page gets a little bit more complex in the denominators that we use. So the first thing I'm going to do is I'm going to rewrite this one as 3 times m plus 2. By taking out the GCF, you'll notice now that there is actually something that these two have in common. The common denominator is 1 of each of the numbers that are on the bottom. The numbers you have on the bottom already are 3 and m plus 2 and m plus 2. So that means the common denominator is 3, m plus 2. What do I need to add to the first denominator to make it the common denominator? The answer is nothing. So you could put 1 over 1 if you wanted, but I'm not going to do that. That's redundant. What is missing from this denominator to make the common denominator? And that is the number 3. So by taking out your GCF, by simplifying your denominators, you actually see there will be repetition in the denominators, and you don't have to use all of these values, because at first glance you would say, oh, my common denominator is 3m plus 6 and m plus 2. But by taking that out, you'll notice that m plus 2 is already there. So now what I have is m minus 12m divided by the common denominator of 3 times m plus 2. 1 minus 12 is negative 11. And now we come to a bit of a crossroads. I believe that it's better to leave it in simplest form. Okay? But however, you might have to recognize an answer choice where this 3 is distributed back into this quantity m plus 2. So either negative 11m divided by 3m plus 2 is correct, or negative 11m divided by 3m plus 6, the distributed form of that, is also correct. So just recognize both ways. Alright, question number 6. Oh, sorry. Question number 5. The reason I keep it simplified is because it's easier then to see where you can simplify if there are any terms that can be canceled out. That's why I like to leave it in simplest form. Question number 6. So the first thing we're going to do here is we're going to factor each one of these trinomials. What two numbers multiply together to make 6, and how do they add up to make 5? So that's x plus 2 and x plus 3. How do I get 4 and add up to 4? That's x plus 2, x plus 2. Remember, common denominator means I need 1 of everything that's on the bottom. I need an x plus 2. I need an x plus 3. And you got to be careful here. I actually need another x plus 2. And the reason I need the other x plus 2 is because there's 2 of them in this one. If there was only 1 over here, then this one would have covered that one over there. But since there are 2 in this case, I need the second one to get my balance across the entire denominator. Okay, so what value needs to be placed in the first denominator in order to make the common denominator? That's another x plus 2. What value needs to be placed in the second denominator? Well, that's x plus 3. I'm going to distribute the x to both of those values. Be careful here, we are subtracting. So I'll be distributing the negative 2 to both of those values. Alright, that gives me x squared plus 2x minus 2x minus 6. All over the common denominator of x plus 2 times x plus 2 times x plus 3. Simplify. X squared minus 6 divided by x plus 2 squared times x plus 3. There is no GCF. This is not the difference of two squares, so there's nothing else I can do to this to simplify it. That is my final answer. Question number 7. What two numbers multiply together to make negative 4, and how do they add up to 3? X plus 4 and x minus 1. That means my common denominator is 1 of everything that's on the bottom, which is x plus 4 and x minus 1. This is an example of how the single x plus 4 will work across the entire denominator. Notice there's only one x plus 4 over here, so I've already written it. What do I need to place in this first denominator to make it the same as the common denominator? So I need to make no changes there. What do I need to place in the second denominator to make it the common denominator? That's the x minus 1. So now I'm going to get x minus 3, no change to the first part, plus 2x squared minus 2x, divided over the common denominator of x plus 4 times x minus 1. Combining like terms, I get 2x squared minus x minus 3. Factoring this trinomial, I find the two numbers that multiply together to make 6, that's 2 times 3, and then I split the middle term by adding them together. So that's going to be 2x squared plus 2x minus 3x minus 3. Grouping, or if you're more comfortable, you can use the box. So I'm going to take out my GCF, which is 2x, and what's left inside is x plus 1. Take out my negative 3, what's left inside is still x plus 1. My first factored term is 2x minus 3. My second factored term is x plus 1. And here's the reason why I keep it in simplest form. X plus 4 and x minus 1. Although it doesn't work out this time, you'll notice if I had multiplied this back together to make x squared plus 3x minus 4, I would not have recognized that these binomials were almost identical. There are times in the future where they could be, and you could cancel them out from here. So be very careful. That's another reason why I leave them in simplest form. Now, because none of these quantities are exactly identical, I cannot simplify any of them, so the answer is that. Please practice further on questions 8, 9, and 10, and have those ready to share tomorrow as either a warm-up or a classroom activity where we talk about how we found our answers to these problems.